How many people in the audience are engineers, design engineers? How many are fabricators or fabricators engineers? General contractors? Any architects? We got an architect, so I have to be careful. We are in a revolution, whether you know it or not. The American construction industry is overpriced, and the American public cannot afford to pay the price of construction. If you look at how much construction prices have come down, it's come down a lot less than the average buying power of the American person or company. And everything in the commercial market is stalled. Nothing's happening. And, you know, as some people have said, don't waste a crisis. This is the time to take BIM, to take Tekla, to take three-dimensional modeling, to take prefabrication, industrialization, and change this industry that is absolutely in the dark ages. The way we build buildings, okay, ain't much different than what we did 50 years ago. I mean, just look at it, okay? Fragmented, nobody talks to each other, the communication systems stink. Architects don't talk to engineers, engineers don't talk to architects. Contractors, you know, half the architects in the world don't even want to tell them what's in the drawings. BIM is going to change that, and it is changing it. And I'm going to take you through a bunch of examples of projects that Thornton Tomasetti has executed using three-dimensional modeling and especially Tekla. I want to thank Darren Hartman, Vice President of the Thornton Tomasetti, and Denny Beck sitting down here for helping me. And if anybody has any questions, want really detailed questions about Tekla, they're going to come up. We got involved in Tekla through Soldier Field. Joe Burns, managing principal in the Chicago office, talked to Ted Phillips, Turner, Barton Mallow, and Alice Hoffman, and said, if you pay for us to send 4 people to London, this is about 2001, 2, 3, if you pay us to send 4 people, expenses, and some reimbursement of salary, we will take X Steel, now called Tekla, and we will make your project happen in 19 months. And we got paid about $1.5 million bonus for bringing that project in on time. The problem with all of our sports work until Soldier Field was we were set up by the fabricators and the general contractors. The drawings were never coordinated. The architect's drawings never coordinated with the structural drawings. We had to put out early packages. We didn't do any design assists. And the claims started coming in on Ford Field, on PNC Park. Almost every one of the major sports jobs that we were doing, we were getting killed with lawsuits. On PNC Park, the GC picked an undercapitalized fabricator. They gave it to the guy that didn't have enough money to finish the job. And halfway through the design, they came to us in our project carrier, put the gun to our head and said, if you don't sign over $10 million, our steel fabricator's going bust. Well, guess what happened since we used Tekla, since we do Soldier Field? DC baseball, Yankees, Jets, Giants, Devils, and now Barclays Center. No claims, very few RFIs. Jets, Giants was finished 6 months early. The Yankees, on a $1 billion project, acknowledged that Thornton Tomasetti's use of Tekla on a $1 billion project saved 4 months. So the bottom line is, and I've spoken at a bunch of engineering conferences, when are the structural engineers in the world going to wake up and start charging for saving money on projects? We do. Most structural engineers, they're scared shitless about asking for an extra from an owner when they're saving 4 months. Convert this into a business opportunity. I mean, it's amazing, okay? We're our own worst enemies. So my premise is that Tekla, BIM, three-dimensional modeling, is going to propel those structural engineers who have any brains and those fabricators who want to work more closely with structural engineers, they're going to get propelled into being the leaders of the team. And I'm going to show you some things that are going on in this industry. Okay? Architects have basically dropped the ball. Okay? They cannot meet schedules. They cannot meet deadlines. They're hung up on aesthetics. And they end up really hurting the industry. Now, I mean, architects do play, obviously, a fabulous role. But on fast-track, design-build, design-assist steel projects, the structural engineer is getting more importance and more fees. On all of our Navy design-build work with Hensel Phelps, our structural engineering fees are double what we would get from an architect. Why? We are the key to eliminating the liquidated damages in those Navy contracts. Because with Tekla and with steel and three-dimensional models, we get our packages out within a month. And they're all design assist with some of the best fabricators in the United States. See how this is going to... So, I urge you all to read this book, Refabricating Architecture. I probably can't read it, but what it basically says, and it's Kieran and Timberlake, who were the Architectural Firm of the Year last year, AIA, who basically say architects need to change. The integration and the linear communication has to change. Process engineers, project engineers, fabricators engineers, contractors, and architects have to become seamless. And in steel and now concrete, in my opinion, Tekla and BIM are enabling that to happen for those people that are using it in the correct manner. So I really urge you to read this book and study these diagrams. They're hard to read, but the one on the upper left-hand corner is basically how it is now. And the one in the lower left-hand corner is kind of why no one's talking to each other. And then you get over here, and what Kieran and Timberlake did is they went to the automotive, shipbuilding, and aviation industry. And they looked at how they build chunks, they build prefabricated sections of airplanes, ships. Cars come to the assembly line in chunks, and there's no reason why buildings can't come to the job site in chunks. Obviously, we're limited by trucking and highway and widths and bridges. But I'm going to show you some things that are being done with prefabrication where we are making a big change. And again, this just kind of shows how, you know, if you think about the doors on a car, they're all made somewhere else. And everything's in the door. At the assembly line, nothing happens with that door except it gets hung on the hinges. And if you look at the mechanical contractors, they are prefabricating bigger and more pieces of the MEP sections and bringing them to the job prefabricated. MCOR, $6 billion a year company, is beating open shop contractors in Southern California by using BIM, prefabrication. They're able to beat hard bid against open shop contractors, a union contractor in Southern California, okay? And it's all because of their prefabrication using three-dimensional modeling and CNC downloads and all sorts of cuts. You should read this book too, if you want to see how bad the construction industry. Broken Buildings and Busted Budgets by Barry LaPatna. And he explains how in the process, there are certain players in the construction team that have more information, and the guy who has the least is the owner. And as a result, the system's broken. It doesn't work. This is an interesting video. This is a system called the TTG system. Slip-form concrete pours, elevators, stairs, everything goes in as it's going up. Vertical risers go in as it's going up. 24 feet a day. Then we mount 6, 7, 8, 10 strand jacks on the top of the building. Steel all comes together on the ground. A Macton turntable goes on every floor. Each floor rotates. Concrete, exterior wall, and up we go. No tower cranes. All steel erection is done no more than 6 feet off the ground. No tie-off. The assembly rate of putting the steel together is 5 times faster than conventional. There's no hook time. This was conceived back when everybody had money. We were going to sell the units at $35 million each. Each owner of a floor would be able to control their own floor. And they could watch the sun come up in the morning from their master bedroom and the sun go down from their cocktail lounge. There's a lot more in the video about the architectural finishes, but this was a real project. Hochtief and Turner financed this video, and we basically went to Dubai and tried to sell a system, and by the time we got there, the bottom was out of that market. But the fact of the matter is, if you just think about the process, why not put together the floors on the ground and lift them? And I've got other slides here. I think one of the most progressive companies in the United States is Chinbro, and I was talking to Chicago Bridge and Iron last night. Where are they? CBI? Back here somewhere? And they're doing the same thing. Chinbro is prefabricating everything in their fabrication facilities on the water. And basically they're in Brewer, Maine, they're in Baltimore, and where's the other one? Can't read it from here, but basically they're prefabricating industrial facilities, and again, chunks. And the project that I'm really impressed with is shown here. I'm just going to go quick through here. Obviously, steel companies that build bridges and can float them in and replace the bridge overnight is obviously the optimum on prefabrication and modular construction. But we moved to Brewer, Maine, to an old paper plant, which put 600 people out of work. And Chinbro goes in and tears down the building, and they set up a modular facility. This is for the Motiva project down in Port Arthur, Texas, with Jacobs and Bechtel, Motiva. They prefabricated 52 800-ton units completely in Maine and barged them all the way down around Key West and up into Port Arthur. And just amazing what can be done. Again, all this modeling, the fabrication, all the piping, everything done, and I'm sure there are other petrochemical and industrial companies that are doing some of this. And then putting them on the barges, 100-foot by 400-foot barges, 20,000-ton capacity. So if you got 850-ton modules, you can figure out, you can put at least 2 or 3 of them on. And they also built that bridge, Stablecade Bridge. And to me, this is kind of, not the normal type thing, but prefabricated construction is absolutely facilitated by 3-dimensional modeling. This is not Chinbro. This is Charles Pankow Builders in California, precast concrete modular schools. They can build a school in about 1/3 the time as conventional. They only work for 2-story buildings. And unfortunately, California doesn't have much money right now for schools, but they're basically beating everybody by a large margin on price and timing. And there's no reason why it can't be done in other types of facilities. And these are the classrooms, okay? I'm really anxious to spend some time today and see Tekla's developments in reinforced concrete. Obviously, steel is way ahead of concrete, but from what I gather, concrete's coming real fast.